All right, today we're going to tackle a topic that sounds like it was pulled straight out of science fiction, but it's rapidly becoming a reality. We're talking about quantum computing. And believe me, it's a field that promises to redefine, well, everything we thought we knew about computers. The implications are just staggering.
And let's just get right to it, okay? The stakes here are absolutely enormous. You know the encryption that protects our most sensitive data, our bank accounts, our private messages, government secrets, stuff that would take a normal computer thousands of years to crack? Well, a quantum computer could potentially shatter it in a matter of minutes. This isn't just a small step up, it's a whole new ballgame. So yeah, this incredible potential has kicked off a brand new global race, a race to build the next generation of computers. We are literally standing on the edge of a technological leap that could be just as transformative as, say, the invention of the first computer or the dawn of the internet itself. So should you be worried? Well, not just yet. Today's quantum computers are kind of in their infancy. I mean, they're powerful, for sure, but they're also prone to errors, and they're not quite ready to break our digital world. But the most important word on this slide is that tiny one at the end, yet. The progress in this field is just exponential. New breakthroughs are happening at a pace that's frankly dizzying. I mean, think about it like this. The computers that guided us to the moon were the size of a room, absolute marvels of their time, right? Well, today, the phones we carry around in our pockets are ridiculously more powerful. Technology doesn't just creep forward. It takes these massive, sometimes unpredictable leaps. And quantum computing? It's getting ready to be the next giant leap. Now, don't expect to be buying a quantum laptop anytime soon. For the foreseeable future, quantum computers are going to act more like powerful sidekicks to our normal computers. Even think of them like a super specialized tool, kind of like how a powerful graphics card, a GPU, helps your computer handle amazing video games. The quantum computer will tackle the impossible problems, while your trusty laptop handles all the everyday stuff. So, what is the secret sauce behind this whole quantum leap? To really get it, we need to go back to the very foundation of computing and meet the revolutionary new building block that makes it all possible. You know, our entire digital world, from your phone to the internet, all of it is built on this one simple but honestly brilliant idea, the classical bit. Fundamentally, it's a light switch. It's either on, a 1, or it's off, a 0. This binary system has been the bedrock of all of our tech for decades, and man, has it served us well. But this is where things get really weird and mind-bending. Meet the qubit. It's the quantum version of the classical bit. And I want you to forget that simple on-off light switch. A qubit is more like a dimmer switch. It can be a 0, it can be a 1, or, and this is the incredible part, it can be a whole spectrum of both at the exact same time. This right here is the source of a quantum computer's unbelievable power. And believe it or not, just existing in multiple states at once? That's only the beginning. Qubits play by a completely new set of rules, a quantum rulebook, if you will, that give them these extraordinary abilities. Let's dive into these quantum superpowers. Okay, first up is superposition. That's the ability to be in multiple states at once. Now, this isn't just some neat party trick. It's a complete game changer. Because of superposition, just a handful of qubits can explore a truly astronomical number of possibilities all at once. We're talking way more data than all the classical bits on the entire planet combined. It's just wild. But all that power is just chaos if you can't control it, right? That's where quantum gates come in. Think of them as the conductors of a quantum orchestra. They precisely manipulate the qubits to perform these incredibly complex calculations. For example, a simple gate can take a qubit that's just a plain 0 or 1 and pop it into that powerful superposition state, unleashing its full potential. Next, we have something called entanglement. This phenomenon is so bizarre that Einstein himself famously called it spooky action at a distance. When two qubits are entangled, they become linked. Whatever happens to one instantly, and I mean instantly, affects the other, even if they're on opposite sides of the universe. This spooky connection allows for a level of coordination that's just impossible in our classical world. Okay, so we've got these qubits, right? They're in a state of superposition, they're entangled with each other, and they're creating this vast, almost infinite landscape of possibilities. So how in the world do you find the one right answer you're looking for in all that quantum chaos? It sounds like trying to find a specific needle in an infinite haystack. Well, the key is understanding that superposition allows for this massive form of parallel processing. So imagine you're trying to find your way through a super complex maze. A classical computer would have to try each path one by one, which could take forever. A quantum computer, thanks to superposition, can basically explore every single possible path, all at the same time. It can find the solution exponentially faster. But here's the catch, and it is a big one. The very act of looking at a qubit, of measuring it to get an answer, forces it to abandon its quantum state. That whole beautiful superposition just collapses. The spectrum of possibilities vanishes, and the qubit is forced to pick a side, becoming either a definite 0 or a definite 1. So you're left with just one single result. So that's the big problem, isn't it? How do you tame all this quantum weirdness to get the one answer you actually need? Well, this is where the true genius of quantum computing comes in. It's all about this really clever trick using something called interference. Think of it like waves in a pond. You can carefully make the waves that represent the correct answer get bigger and bigger, while making all the waves for the wrong answers crash into each other and just cancel out. That way, when you finally take that measurement, the odds are overwhelmingly stacked in your favor that the qubit will collapse into the right answer. It's brilliant. And when you put all three of these quantum superpowers together, superposition, entanglement, and interference, you unlock the ability to solve problems that are currently way beyond the reach of any computer on Earth. We're not just talking about difficult problems. We're talking about problems that are fundamentally impossible for classical computers to ever solve. So it's really that perfect combination: superposition to explore every possibility, entanglement to create those complex, spooky links, and interference to find the one right answer in the crowd. That's what fuels the revolutionary potential of quantum computing. It's a whole new way of thinking about computation itself. And the stuff we could actually do with this? It's honestly mind-blowing. Imagine designing new life-saving drugs, molecule by molecule, creating financial models that can predict market changes with uncanny accuracy, building AI that can truly learn and reason, solving logistical problems that could totally revolutionize global trade. This is the kind of world quantum computing promises. Look, the theory is there, the math works, the potential is absolutely undeniable. Right now, the brightest minds in the world are in a race against time to build the actual hardware that's going to turn all these incredible theories into a reality. We are right on the verge of a brand new technological revolution. The quantum era, it's really not a question of if anymore. It's just a question of when. And as we're standing right here on the edge of this new age, it kind of forces us to ask a really big question. Once we have this almost godlike computational power, what's the first impossible problem we should choose to solve? The future is quantum, and it's up to us to decide what that's going to look like.